So this lesson is over using some of our chords, and we're going to use chords to cut up our circles. And once we cut up our circles, we're going to talk about arcs and things like that. So there's a few theorems here that we can use, and once we find these theorems, basically what you'll be doing is finding missing angles or side lengths. Pardon the little ones coughing in the background. We've got a bug. Sorry, I'm trying to get this video out. We'll go ahead and move on here though. So in here, again, we can pause the video if you need some time to copy down theorems. I'm not going to waste a bunch of the time in the video. I would just copy these down, take them in. Hopefully we make sure we understand what's being said here. In theorem 10.6, we have congruent corresponding chords theorem. That just says in the same circle or congruent circles. So this could be happening in two different circles. It said if two minor arcs are congruent, if and only if the corresponding chords are congruent. So those go hand in hand. So basically, if I know arc AB is congruent, then I know segment AB is congruent to segment CD, if I know those arcs are congruent, and vice versa. You can say that when it says if and only if in the middle, that just means the proof works both ways. You can start with the segments or you can start with the arcs. It doesn't necessarily matter. Perpendicular chord bisector theorem. If a diameter of a chord is perpendicular to a chord, or excuse me, if a diameter of a circle is perpendicular to a chord, then the diameter bisects that chord. And that's going to come in pretty handy for us when we go to construct things inside that circle. Just know that if a diameter ever hits at a 90-degree angle, that means that that chord is bisected. If a chord, let's see, 10.8 says if one chord of a circle is a perpendicular bisector to another chord, then the first chord is the diameter. So basically it's saying if this cuts this in half and is perpendicular to it, we know that it must be the diameter of the circle. So it does go through the center, and that's just one of those things where if you move that segment, this chord FD, anywhere around the circle, in order for it to be perpendicular to the diameter, it would have to be cut in half. And if those two things are true, that means we know it's the diameter. Again, you can rewind and get those notes all the way copied down. I don't want to burn up a bunch of the video time so that you can copy notes. You can always pause. But in example 1, we have an example that says circle P is congruent to circle Q. So these are two separate circles here. It says FG is congruent to JK. Those are the segments. And then it says, and measure of angle JK is 80 degrees. Find the measure of angle FG. Well, if we know these are congruent circles, and the only reason we know that these are congruent circles is because these radius are the same length. So by default, these things are the same exact size. And that means if this chord is congruent to this chord, the arc created GF must be 80 degrees. Another type of example we can use, again, keep in mind here what's going on. We have the diameter of the circle JL, and we have a 90-degree angle intersection with chord HK. That means that this is being bisected. So right away, we know that the length of HK, this chord, we know automatically by default that HN is 7. So if we know HN is 7, because it has to be congruent to the other side, we can just add them both, or we can say HK is 2 times 7. Either way, the book says it. HK is equal to 2 times that 7, but either way, we get HK, excuse the noise in the background, guys, HK is equal to 14. The second part, the measure of angle MK. Now again, keep in mind this arc is being created by this chord that is being bisected. So if the chord itself is being bisected, that also means that the angles that create these things are being bisected, and they're both 90 degrees. So by default, we can say 70 plus x is equal to 11x, and that just takes a little bit of algebra to solve that. 11x is equal to 70 plus x. We subtract the x to the other side, and we get 10x is equal to 70, and we get our solution for x 7, and then if we want to find the measure of angle HK, we need to plug that in. So again, don't just answer for X. Keep in mind what the problem's really asking for. The problem's asking for the measure of arc HK. We know that we need to plug in X, or excuse me, 7 for X. So if I just plug it in for the first one, I'm going to say 11 times 7, and I'm going to go 77 there. And I know it's twice as big as that 77. So if I just take 77 times 2, that will get me where I need to be. So 7 times 2 is 14. Carry the 1. 7 times 2 again is 14. Plus 1 is 15. So the measure of arc HK should be 154 degrees. Now, sometimes students get a little ahead of themselves when they're solving things like this. So we found both. HK is 14, and the measure of angle HK is, or arc HK is 154. Sometimes students will get a little bit ahead of themselves and just assume. I apologize for the background noise though, guys. Some people will assume that because these are both 90, that this arc is also equal to 180, but realize that's not the diameter, that's just a chord, so it can't be the whole 180 degree arc. Okay, so this one is actually one that would have been pretty hard to explain without having the solution. This is something that's actually pretty practical, and I spent a summer working for the feed store, and they would have to do things like this. Not only would they have to account for the water pressure, but they would have to figure out how much pressure each zone had and how far the sprinkler heads would reach. Now, when you're talking about this one, it says 3 bushes are arranged in a garden shown. Where should you place a sprinkler so that it has the same distance from each bush? Now, again, when you're talking about the closest distance to a certain spot, we said that's a perpendicular line. Well, if we make a perpendicular line, like in step 2, if we make a perpendicular line going down between B and C, and a perpendicular line going towards that same spot in A and B, you're looking at what you've created was a circle. So in this, when I create this circle, and bear with me now, we have one that's as best as we can get it. We've created this circle now where this is essentially the radius to all of these spots. So the sprinkler is going to need to be at the center of this circle. So if you have something like this in the future and you're trying to figure out the closest thing between 3 different points, you can use a circle because it's going to be the radius where the things are bisected. So again, I know it's not exactly the same, but that's the circle that's been created so that the sprinkler can hit these 3 bushes. And again, this is something that's pretty practical where you're talking about different things being able to reach, one thing being able to reach multiple things all at once. Again, I'm not going to make you construct one of those on your own, but we have covered 3 different types of example now. Hopefully we have enough here to be able to pause and kind of try some of these on our own. Again, you don't necessarily have to have all the work every time, but I'll work them out for you as well. So pause the video, try these, because these are very similar to ones you'll see on the homework, and then on the quiz again early next week. Okay, so for those of you that just want to check and then go ahead and forward through, I have the answers right here. We have, for number 1, you should get 110, number 2, 105, number 3, 10, and number 4, 144. So if we look at what we have here, 1 and 2 are pretty similar to what I showed you in the very first example. 3 and 4 are pretty much like example 2. So if I know my segments are the same here, basically if I know the measure of angle AB, or arc AB, excuse me, I know the measure of arc AB is 110. Well, if 9 is the length of segment AB and 9 is the length of segment BC, that means the arc also has to be the same 110. 150 on the measure of angle AC. Well, if I look, I have arc AC right here, that's 150. And if I want to find AB, well, if I want AB, I have to go right here, and that would be my 105. If this is 150, keep in mind, these have to be the same to complete the rest of the circle. So the math there, again, I know it's kind of confusing because it changed the measure of the arc. So if I know the measure of arc AC is equal to 150 degrees, that means that the rest of my circle is going to be the rest of the 360 degrees. So if I take 360 minus 150, I get my remainder, which is, let's see, 0, 1, 2. So I get 210 for all of the circle. So I get 210 for ABC, this major arc right here. ABC is 210. Well, if I just want AB, I need to take that 210 and divide it by 2, and that's how I get my 105. So if I take 210 and divide by 2, I get 105. Sorry, I'm changing colors here. So we really don't need to punch this in, but you know 210 divided by 2 gives me that 105 that I get up above. So for those of you, I know that was kind of misleading because they kind of assign two different angles to the same thing. They'll do that from time to time in the textbook as well. It's not always just assumed to be the same all the way through. You have to make sure you pay attention to what's given. Number 3 is pretty straightforward. It wants you to find the length of segment CE. Again, that's almost exactly like what we did in the previous example. So let me get this stuff out of the way. So I'm going to group this stuff together. Cool. And now hopefully I can move this. We'll get this out of the way here. Okay. Now example 3, again, we know that CE is 5, or excuse me, we know that CF is 5. That means FE is also 5. So this whole length CF is got to be, or excuse me, CE, holy smokes, guys, CE has got to be 10. CE is equal to 10. So now we want to do the measure of arc CE, and again, we know those two things are bisected. Do not assume that that semicircle gives me the arc of 180 degrees. The only arc that's 180 degrees is the arc of the diameter. The only way I can find this is if I set 9x equal to 80 minus x. I add the x to both sides. I get 10x equals 80. Again, don't get carried away and think that 8 is your answer just because you found it. That is not what it's asking for. It wants the measure of arc CE. I'm just going to plug it in where it's easiest. 9 times 8 gives me 72. That's only half my arc. I'm going to take that answer times 2, so 72 times another 2 is going to give me 414. So 144 degrees is the arc. Again, we have another theorem. This one's pretty similar. It's just saying chords are equidistant if the segments are congruent. Again, there's no way for these things to be congruent unless they're the same distance from the radius. Sometimes you'll see some that overlap. That doesn't mean that the chords aren't the same length. You could potentially see a chord, and let me get a color here that you'll see, but you could potentially get a chord like AB could do this, and it's still, if you'll notice, if it's the same length as CD, it's still the same distance away from that center point. So don't think that they're always going to be exactly the way they appear on the very first example. They could rotate those chords anywhere on that circle and it would still be the same length away from the radius. There's an example that goes along with this. If we look at example 4 here, it says in the diagram we are given the fact that, and oh, I apologize, here's the diagram it's talking about. It's saying that QR and ST are both 16, and it's saying that CU is equal to 2x. It gave that to us and it drew it in there, and CV is equal to 5x plus 9. So first of all, what we're going to do is we're going to find this value of x to figure out exactly what that distance is. And we'll kind of pick this one apart. This one's actually got a lot of layers to it. If we're not really sure how to set it up, it's not going to do us any good to start it. Ollie, hush, buddy. Hush. Lay down. Shh. Lay down. Lay down and be quiet. Okay. Okay, so our first step is to find 2x. We're going to let 2x be equal to 5x minus 9. If we solve for x here, I'm going to subtract the 5 to the other side, and I get negative 3x equals negative 9. I solve for x, and I get x equals 3. Again, doesn't do us a whole lot right away, but we could at least find the length of, let's say, UC or CV. It doesn't really matter which. I'm just going to plug it into UC because I just have to take it times 2. So 2 times 3 gives me my length of segment UC, which is equal to 6. Now, this next part, I don't know if you guys will put this together right away. It will come with practice, but if we want to know the radius of a circle, and if you'll look here in the circle, we really aren't given our radius anywhere. We're given a distance between the chord and the radius and a chord and the radius, but really this CW does nothing for me. But if I construct a radius, bear with me now, this is not going to be exactly perfect, but if I construct a radius, and just because I used that 2x, I'm going to use point Q, and I'm going to construct a radius. Let's try and make it a little bit better than that. It's not going to be great, but I can do a little better hopefully here. Sorry, my son is all kinds of climbing on me right now. Hold still, Ollie. Okay, there's my radius. Now, what did I just construct? Well, I just constructed a right triangle, and I know at least one of the sides. So I know that CU is 6 in this right triangle. Well, that does me a little bit of good, but still I need at least 2 sides in a triangle to find the third. And even better yet, I have a right triangle, so if I find the second side, I can use the Pythagorean theorem. The very first thing given in this thing is QR and ST are congruent, and they're both equal to 16. So if I know the whole length of QR is 16, I know that QU has to be half of that, which is 8. Well, now I can use the Pythagorean theorem. I can say 6 squared plus 8 squared is going to give me my radius squared, or C squared is my hypotenuse. 36 plus 64 equals C squared. 36 and 64 is 100. C squared, if I square root both sides, I find my radius is equal to 10. Again, you can say R equals 10. You could have also realized that that's a 3, 4, 5 triangle, and it's just 6, 8, and 10 instead of 3, 4, and 5. They took 2 times each of those. You could have absolutely gone the other route and used 5x minus 9 and constructed the radius to S. It would have been the same thing. It's still 6. The length of SV is still 8. So either way you did that, you absolutely could have gotten the radius. Again, just because the radius is already constructed somewhere doesn't necessarily mean that that's the easiest route to solving it. So again, keep in mind this one did us no good. We wanted to construct that right triangle inside of there. That's about as hard as they get in this lesson. So let's take a second and actually try this one. Again, guys, keep in mind it's going to be pretty easy to go ahead and skip into the homework. Going to be pretty easy to go ahead and skip into the homework, but unless you actually practice some of these on your own, going to be kind of tough to pull off. Again, pause, try it. I'm going to go ahead and start working it out. Again, what we're given is 2 chords that are the same distance away because they're the same length. JK, LM are both equal to the same thing. That means we know that NP and NQ have to be the same length. So again, that's what I'm going to start with by finding one of them. 3x is equal to 7x minus 12. I subtract the 7 over negative 4x equals negative 12, and I get x is equal to 3. I'll plug it in. It doesn't matter where. I'm just going to go the easier way and plug it in for that 3x. 3 times 3 is my 9. So again, what we want to do, we found this is 9 right here. Now I'm going to go ahead and construct a right triangle using that. And this time we know, again, we know that the whole length of JK and LM, so JK is 24. That means that half of it right here is 12. And I can use my Pythagorean theorem again. 9 squared plus 12 squared is equal to, we'll just call it the radius because that's what we're finding, the radius squared. 9 squared is 81 plus 144 is equal to R squared. Let's see. We add up 81 and 144. We get 5, 2, carry the 1, 225. If we take the square root of 225, we get r is equal to 15. So again, that's about as complex as it gets, you guys. The homework assignment is posted for you. This shouldn't be that hard to get through. Email me if you have any questions. Thanks, guys. Have a good day.